Hello, my name is Adrian, and this is my Physics Lab 5 on collisions. The purpose of this lab is to compare the observed momentum of a ball after a collision with a wall to the predicted version using GloScript computational model. Some principles are the conservation of momentum and Newton's third law, which states for every force in nature there is an equal and opposite force. Some results that we'll see later on are final momentum is equal to initial momentum, but for the experiment result, the final momentum was not equal to the initial momentum. That is because there was some external forces. Here are some models and equations slash derivations. On the left is momentum derivation, and on the right is conservation of momentum. For this experiment, the procedure was to record a ball rolling into a wall and bouncing back and upload the footage into Tracker and use the Tracker software to plot the position points across different frames to gather position and velocity data. And lastly, use the Tracker data as initial conditions for position and velocity to create a computational model in GloScript. The object or system was the foam ball, and the surrounding was the friction from the carpet and air resistance. This is the Tracker model. Some of the conditions were friction force, air resistance, and non-constant velocity. This was a GloScript code, which has the ball's initial position and velocity, and the wall's initial position and velocity, which is 0. And yeah, and it uses the position update formula, as well as it calculates the momentum. These are the models of the GloScript. The conditions were no net, external force, and constant velocity. And here's the result at the bottom. On the top right, you see the velocity versus time model. And on the bottom right, you see the total momentum versus time model. As you can see, the total momentum is constant. And for the velocity, the ball velocity changes direction. Here's some more results. The top is the predicted, and the bottom is the observed. The pre-collision, the predicted and observed models are constant. However, in the observed experiment, the momentum is decreasing because our velocity isn't actually constant and F net isn't actually 0. External forces like friction and air resistance reduce the ball's velocity and momentum. Some sources of error are drag force, air resistance, and other outside forces, as well as human error from the tracker, since I had to click through and individually click through each tracking. As you can see from the top image, you'll see drag goes in the opposite direction of the direction of motion, which slows things down. Some additional questions. What does it mean for momentum to be conserved? In an isolated system, the total momentum before an event, such as a collision, is equal to the total momentum after the event. As you see from this equation, mv1 initial plus mv2 initial equals mv1 final plus mv2 final. And what if there was no external forces in the observed model? If there's no external force in the real life model, then the ball would bounce off the wall and travel in the opposite direction without ever slowing down. That's it. Thank you.